Let's start example 1.2, an oscillation skateboard. So you can read this statement by yourself. I will just explain using diagram. So this is the half pipe designation, and where you put it, the skater which is moving in a circular form. So here you can see that R is fixed, so it's mean that there are constraints, okay? And here phi, which is angle, which shows position of the skater, okay? So it's the radius of this half pipe will be 5 meters. You have to find the time actually, okay? So first you see there are forces. There are two forces, weight and norm. So after putting values, you can see in this diagram, and this diagram shows when we split weight into its components, we will get mg equals 5. Okay, you can put there this value, and the minus normal shows and that are moving against the direction of this skater. So you have studied two forces in two-dimensional polar coordinate system. Am I right? These two forces. I know you know very well. If you don't know about it, then you can watch this first. You can take the lecture. After that, you will. It's easy for you. So the things are, after taking this r derivative, second derivative, it's constant. After taking derivative of some constant value, it gives its obvious 0. So the remaining terms are same. And if we talk about the force along angle, so this is equals to weight minus weight weight times r. Okay, so after putting these values, it's obvious after taking this, due to this radius, this constant, this fixed constant value, we will get 0. So you can put here the m are same, okay? The m and this m will cancel out each other. And the second derivative is it. You can write it in this form. Okay, so you can see we will get, after cancelling m, we will get these equations. Am I right? So here r is, you can put there. Okay, it's a simple equation you can solve by yourself. This is second derivative, and you know that omega square, which is angular velocity, which is equals to g over r. Okay, and sine phi, which is approximate equals to phi, which is very small angle. So you can put it there, phi. Okay, so we consider here phi value. Why? You can understand that how we can use this thing. So okay, let's take derivative this value. After taking derivative and after taking second derivative, we will get these form. Okay, now put these values again to this. Okay, and in second derivative and the phi value, we will get this. Phi is equals to over e r t, which is exponential notation. Okay, so ERT and this ERT will cancel out, and the remaining terms are same. After taking square root, you will get the complex value, which is in negative and positive form. So when we solve the complex values, so we have to take some equation. So this is the required equation, and this is the general formula of this equation. So we can take this value after putting, and we know that by using eigen equation we can solve it. The sine omega t and cos omega t we put there. Okay, so by applying initial condition, when in t time 0, okay, in t0 time is 0, we will get phi naught, its value of angle, which is constant. So not constant, but it's varying with moving scatter. And t is 0 will get 0, t 0, and phi 0 equals to a. By solving it, you can see when you put the 0, it's the whole term is 0, but remaining term is this. Okay, we'll get only a. So, and sine omega t is obvious this one. By eigenequation, now it's the real equation. Okay. Like eigenequation shows when there is a complex value in power, you will equate it by using cos theta plus I sin theta. Okay, when time is 0, it's always all over the theta will get 0. Okay, so we will get b value. Okay, this phi naught shows that when t0 will have an equation of phi 0, so that's why we put it there. And after solving it, sine 0 is always 0, so it gives a value of b. So after solving it, now you can see this equation above. You will again put it there. B value gives a phi naught. So put the value of b in this equation. You can see there. So b replaces phi naught, and this is the equation we will get. Now take derivative. Okay, after taking derivative, this is the equation. Sine theta will change into cos, and cos will change into sine with negative sign, and omega is obvious. Now, when time t is 0, cos 0, sine 0, and t 0, we will get a omega. Omega is what? It's an angular velocity. In some time, when time is not 0, it's varying. So in time, we will get phi naught cos omega t. Okay, because you can see the term is, or it's always will get 0. Okay, the time period of the skateboard oscillation is this. You know that after arranging these terms, omega t is equals to 2 pi, because the sphere is moving in 2 pi radial form. Okay, 360 degree motion along a half pipe. So t is equals to 2 pi or omega, and after putting the values, we have required the value of r, and g we know 9.8 meter per second. Okay, so what we'll get time equals to, after putting the value of this in this formula, we will get 4.5. So this is our required value. This is our required what we want. Okay, thank you.